Hello and welcome to this presentation about debugging. The intended audience of this is Year 11 and 12 computing students. My name is Mr. O'Mara and I teach senior computing. So let's have a look at what we're talking about today. The study design tells us that we need to know about debugging and testing techniques for checking modules function correctly, including the use of breakpoints and the use of debugging statements. Now that's all I'm doing in this presentation because it was just too big when I had all of the points in, so those ones in grey, they're going to be in the next presentation. One thing I'm also including, it's not in the study design but I think you should know about it, is commenting out code as a way of managing debugging. So we'll have a look at that as well. So our learning intention is that students can explain the purpose and use of breakpoints, debugging statements and commenting out code for debugging. Let's have a look at breakpoints first. These are actually the ones that I probably use least, but that's a kind of lack of professionalism on my part. I think that they're certainly a wonderful resource. So what it does is you put in a point, it's a red dot in the IDEs I'm aware of, and it temporarily halts the program at that point. Now you can achieve this by commenting out the rest of your code, but if you're working with a really big program, you don't want to have to comment out, hundreds of lines, potentially thousands of lines of code. You can just say, hey, this is the point where I want it to stop. It lets you have a look at the current variable values. What's in the memory? The program call stack, I don't know what that is. And the program flow and logic, I certainly know what that is. So sometimes you've just got a whole lot of stuff happening in a program and it just blurs by really quickly. This is a way of saying, hey, get to this exact point here and stop. But it's even more clever than that. And I'll show you about that in just a tick. So here's an example of it in Thonny, which if you haven't seen before is a fantastic little IDE for Python. So that pink dot there represents the breakpoint. So the code won't run at this point, and you'll see that this num is still 17. I've got used the Windows menu to open up the variables, and so this num equals 7. So I actually didn't even need to print this num. I did it down there. That's a technique we're talking about later in this presentation, but I could have just looked over in the variable window, and we know that line 5 hasn't run because if it had, then this num would in fact be 34. So that's what it looks like in practice. But you can be quite sophisticated about how you use breakpoints. There's this thing called step over, and this basically lets you, you run the current line and then the next line runs in the current scope or function that you're in. So it does get a little bit complicated when the next line is a function or and that sort of thing. So basically I'm really reading to you off the screen here. So we're executing the current line and we're moving forward one step. If the current line contains a function call, it'll run the entire function. So if I'm saying run next line, then next line it'll do everything, because the function is a bundle of code. Step into moves into any function, allowing me to inspect the code within that function. So it moves me in there and I'm guessing that I can then control that line by line. Or maybe it just takes me into the function. Step out completes the execution of the current function and pauses at the line immediately after the function was called. So as you can see, there's quite a lot of power in what we can do here. And it helps you when you've stepped into a function and you want to return it to see what happens once it's returned the data. Now, breakpoints are obviously really good when you're using something like Thonny for your IDE, but you don't have to be using an IDE to use it. You can get extensions which will connect from your IDE to your web server or to your browser and that sort of thing, so that you can have the same functionality when you're coding in PHP or JavaScript in our situation, or any other language you choose. So, what is the value in using a breakpoint? I expect your answer would be something like, it allows us to finally control where we stop so that we can see what the logic is of the program and where variables are, as in what the value is. So debugging statements. Now I actually use debugging statements all the time. I think of it as getting the computer to tell you what it's thinking. So they're lines of code that are deliberately added to display information about the program execution to help you find errors, such as what does number equal at this point. In Java, JavaScript, you've got console log, which I use all the time, but you've also got console error and console table. You can use an alert if you want. I certainly use alert a bit with junior classes because it's very quick and obvious, but it really breaks your flow in terms of testing. I'd rather have my console window open with F12 and be reading it there. So I quite like console log. In Python, you don't have anything quite so handy to hand, so just print it in the program. In PHP, you can echo. Now, an echo has upsides and downsides. I use them a lot. Print_r is good because you can't echo, for instance, an entire array, but you can print_r or var dump an entire array. So they're good for seeing a bit more detail. You can get yourself into trouble when you're echoing when you're using cookies, but that's a whole other problem that we're not going to worry about today. But there are opportunities for debugging statements in all of these options. In pseudocode, they just say use output or display. So what is your value? What is the value in using a debugging statement? So you think about that and I'll have some coffee. The value is that you get to see what the computer's thinking. A lot of the time, it seems like it's behaving mysteriously. You know, is it calling this function? So you put a debugging statement in and say function called. You go, oh yeah, okay, it is doing that. Must be the next thing that it's not doing. I'm a huge user of these. Commenting out code. This isn't mentioned in the study design, but again, this is one of my go-tos. If I don't know if I've got a huge block of code and I don't know which bit of it's breaking, I will take out the whole section and then run it, and okay, error's not happening. And then I'll reintroduce it bit by bit by moving what I'm commenting out. So you can isolate problematic sections and you can change how much you're isolating. And you're testing your hypothesis. My hypothesis is that this big block of code here contains the error. But if I comment it out and the error still happens, it might still be an error of logic that was contributing to, but it gets you in the right direction. And you're identifying the source. You're removing the executable code without actually taking it out of the program. You know, I'm sure there's a temptation to just go, I'm just going to delete all of that. In fact, I've seen students do that. Oh, it was annoying me, so I deleted it. Well, if it's really annoying you, comment it out. Now, in pseudocode, it says to use these conventions here. In pseudocode, you can use whatever you want. I confess I just use single line comments in pseudocode, but there's multi-line. Multi-line's good if you're writing a lot. Python uses the hash and the 3 single talking marks there. I almost never block out sections, or if I do, I just use the single line repeatedly. But, you know, horses for courses. Some people who pretty much only code in Python will talk about hashing out a line. I'd prefer to call it commenting because Python, that's just the way it does it. JavaScript and PHP actually do it exactly the same way as they recommend here for pseudocode. So slashes for singles and /* and then */ for multiples. You can also find a toggle for here, toggling your line comment, toggling a block comment, so that you can actually highlight it and then say, okay, take all of that offline. Off it goes. I want it back, highlight it, back. So you don't even have to know extra commands for putting it on and taking it off. It's just the opposite of what it was. Very, very handy to do when you're using this technique. And you can even do block comments. You don't even need to remember it. It's there in the menu if you want it. So let's see what we know. Breakpoints, these are true and false questions by the way. Breakpoints in an IDE are only useful debugging code that runs directly within the IDE itself and cannot be used for server-side code or browser-based JavaScript. No, that's false. Yeah, it's probably easier when it's running in the IDE, but absolutely it will run in those other environments. Debugging statements such as console log in JavaScript or echo in PHP must be removed from code before deployment to a production environment. Yeah, I think must is the right word here. That's true. Listen, if you dug through all of my code, you'd probably find the odd console log. I hope you wouldn't find any echoes for this sort of purpose in there. But yeah, they should be taken out before you go into production. When using breakpoints, you can inspect the values of all variables at a specific point in execution and follow the code line by line to understand program flow. Yes, that's true. In fact, it's very much the definition of what a breakpoint does. Conditional breakpoints, which only pause execution when specific conditions are met, now I actually haven't talked about these, are less efficient than adding memory temporary if statements to your code when debugging. No, they're not less efficient. They're actually hugely more efficient. And finally, debugging statements provide an immediate pause in execution that allows you to inspect variables in real time, whereas breakpoints require the program continue running while outputting information. That's false. That's actually backwards. Debugging statements, the program will still continue to run, and a breakpoint will actually stop the program running. So that's the end of that presentation. I hope you found that useful, and if you're looking for the stuff about the formal testing, well then that's in a separate presentation, or a separate video in this case.